Hello everybody. Well, today we're going to talk about A to Ds. So what is an A to D? Well, an A to D takes in analog and puts out digital. So why might you want to use, or what would you want to use an A to D for? Well, typically we use A to Ds to measure things, and usually on the front end of an A to D is a transducer. All right, and in this transducer comes in some sort of environmental thing. Could be pressure, could be temperature, could be almost anything. So let's assume that today we're going to do a temperature sensor. So we're going to put in temperature in here. All right, and this transducer will take that input temperature and put out a voltage. And typically a transducer, if we were to plot its input and output, we would have volts on one scale and temp over here. And as the temp goes up, the voltage goes up. And if we got a good temperature sensor, this hopefully this is pretty linear. Okay, so now we have this device, a transducer, that takes in temperature, puts out voltage. Now we need to convert that into something that we can use in digital form. So we put in here an A to D. And usually an analog to digital converter, you'll see it abbreviated like this. All right, and so volts comes in, some sort of digital signal comes out, usually in a register. And an A to D has one additional port, and it's called the reference port. All right, and it's normally a voltage. All right, so now let's talk about what this thing does. So we know it puts in, it takes in some voltage and it puts out digital. So the output of this A to D in digital form in most A to Ds is equal to the voltage in over the voltage reference. Okay, and that the reference voltage is usually called Vref in data sheets. All right, times its resolution. Now the resolution of A to Ds is normally spec'd in the number of bits it can resolve. And some of the typical resolutions of A to Ds is 8 bits or 10 bits or 16 bits or 24 bits. So let's go through an example. Well, first of all, let's think about the resolution in the spec sheet on our PIC 18F series. The resolution is 10 bits. All right, now we know that that most processors are binary, and the resolution is 10 bits, so it can revolve something to 10 to the 24. This is kind of a number you want to remember. All the powers of 2's up to either 12 or 16 you want to remember. 2 to the 10 is kind of a common number, 1024. So let's go through some examples. Let's say, for example, that let's assume that Vref equal 1 volt. Let's assume that Vn equals 1 volt. All right. By definition, our A to D will output a digital output of Vn over Vref times 1024. In our example, 1 over 1 times 1024 equals 1024. So if we do an analog to digital conversion with 1 volt in, 1 volt reference, it will output a number of 1024. Let's take the case where Vn is equal to half a volt, so the output is equal to 0.5 over 1 times 1024 equals 512. Let's take, for example, we put in 1 1 millivolt. So now the V out is equal to the smallest step we can read, the smallest step is 0.1024 millivolts. So that's the resolution. So guys, this is part of the story. We'll pick it up in the next in the next session. So long.